Hello everyone. In this I will be discussing about the thyristor gate characteristic and the turn on methods of the thyristor. Myself Deepashri AP, MTech in Digital Electronics. O, L and OV. OL, OV. This region. Defined by minimum value of the gate voltage and the current required to trigger all devices at minimum rated junction temperature. So it is a required minimum value of gate voltage and the current required to trigger all the devices. So if we want to trigger the devices, then it should be operated in that region. It is forbidden region for the firing circuits. The third region is ON and OM. Here we can see that ON, OM. Operating points S, which may change from S1 to S2, that is S1 to S2, must be close as possible to the permissible PG, that is PG curve, and must be contained within the maximum and minimum limits of gate voltage and gate current. We can say that ES equal to OH. ES equal to OH. A thyristor can be considered as a charge control device. With pulse firing, if the frequency of firing F is known, the peak instantaneous gate power dissipation Pg max can be obtained by Pg max equal to Vg/Ig, which is equal to Pg average divided by Ft, where F equal to 1 by T1, frequency of firing or the pulse repetition rate in hertz, and T is equal to pulse width in seconds. SCR turn on time can be reduced by using gate current of higher magnitude. If T is the pulse width, if this T is the pulse width, if this T is the pulse width and T on SCR turn on time, a duty cycle is a ratio of pulse on period to the pulse time of the pulse. That is, here it is given by delta equal to T divided by T1, which is equal to F into T. 1 by T1 is F, so F into T. So I can say Pg average by delta will be less than or equal to Pg maximum. This is the pulse gating. Turning on methods of thyristor. We can also say this turning on a word called triggering. Triggering means turning on. Turning on of this SCR, we can also, in other words, we can say that it is turning the SCR from forward blocking state to forward conduction state, and this we call it as triggering. The various SCR triggering methods are forward voltage triggering, thermal or temperature triggering, radiation or light triggering, dV by dt triggering, gate triggering. Let us see each one in forward voltage triggering. So So here we can see the SCR here. In this, in a forward bias of biased SCR or thyristor, we know that junction J1 and J3 will be forward bias and J2 will be in the reverse bias. So increase this bias voltage will, so if we increase this bias voltage across anode and cathode, it will narrow down the width of the depletion region of J2 at a particular voltage. At particular voltage, this depletion region will vanish. At this stage, reverse biased junction J2 is said to be have avalanche breakdown, and this voltage we call it as forward breakover voltage. As soon as the breakdown at junction J2 occurs, current starts flowing through the anode to cathode of the SCR. Already this J1 and J3 is forward biased, and if the breakdown occurs at J2, then the anode current starts flowing from anode to cathode. The value of the anode current is only limited by the load. The SCR is now in its conduction mode in forward direction, that is from anode to cathode. This is forward triggering method of turning SCR on. Normally, this method is not used to turn on SCR as it may damage it. There is a possibility of damaging of the SCR because of breakdown in J2. So, normally this method is not advised to use. Generally, the forward breakover voltage is less than the reverse breakover voltage, and hence reverse breakdown voltage is considered as final voltage rating while designing SCR. If anode voltage is reduced below forward breakover voltage, the SCR will continue to conduct. The SCR can now be turned off by bringing its anode current below a certain value called the holding current. If we want to turn off our SCR, once it is turned on, if in any way with the help of gate pulse or anything, by removing the gate pulse, we cannot turn off the SCR. It will be in the conduction mode itself. So to make the SCR to turn off, we have to make the anode current below the holding current. That is the minimum current required to hold the thyristor on. Next is gate triggering. Here we can see the circuit, and in this the gate pulse is given with respect to gate to cathode. That is, positive is given to the gate and negative to the cathode. Gate triggering is the method in which positive gate current is flow in the forward biased SCR to make it on. That is already this SCR is forward biased. That is, anode is given positive and cathode is given negative. J1 and J3 will be forward biased, and gate will be provided with the positive voltage so that it may forward biases the junction J2 also. Gate triggering is in fact the most reliable, simple and efficient way to turn on SCR. In this method, positive gate voltage between gate and cathode terminal are applied in forward biased SCR, which establishes gate current from gate terminal to cathode. When a positive gate current is applied, gate P layer is flooded with electrons from the cathode, that is N side. This is because the cathode N layer is heavily doped as compared to the gate P layer. Since the junction J1 and J3 are already forward biased, the injected electrons in gate P layer may reach junction J2 and hence reduces the width of the depletion region. This results in the reduction of forward breakover voltage. The more injected electrons in gate P layer, the more will be the chance of electrons reaching J2. The more the value of the gate current, the more will be the reduction in forward breakover voltage. Thus, the gate current and the forward breakover voltage are inversely proportional. So here we can see the definition for latching current and holding current. Latching current is defined as minimum value of anode current which must be attained during turn-on process of SCR to maintain the conduction even when the gate is removed. That is minimum amount of current which is attained during turn-on process of SCR to maintain in the conduction mode even after the gate is removed. Holding current, it is defined as the minimum value of anode current below which it must fall for turn off and SCR or turn off of the SCR or thyristor. That is, below this holding current, SCR will be in the turn off condition. Next is dV by dt triggering. This technique is turned on by changing the forward bias voltage with respect to time. That is, dV by dt itself means rate of change of voltage with respect to time. The junction J2 is in reverse biased. In the forward blocking mode of SCR, a reverse biased junction may be treated as a capacitor due to the presence of space charges in the reverse biased junction. Let us assume its capacitance to be C farad. Generally, the forward breakover voltage is less than the reverse breakover voltage, and hence reverse breakdown voltage is considered as final voltage rating while designing SCR. If anode voltage is reduced below forward breakover voltage, the SCR will continue to conduct. The SCR can now be turned off by bringing its anode current below a certain value called the holding current. If we want to turn off our SCR, once it is turned on, if in any way with the help of gate pulse or anything, by removing the gate pulse, we cannot turn off the SCR. Temperature triggering. It is also called thermal triggering. In the forward blocking mode, that is, in this mode, J1 and J3 will be in the forward bias condition and J2 will be in the reverse bias condition. There will be a flow of reverse saturation current across the junction J2. This will increase the temperature of the junction, which will result in further increase in the reverse leakage current. So, due to the temperature increase, it will increase the leakage current. This increased leakage current will again increase the junction temperature. So, as the leakage current again increase, the temperature at that junction also again increases. Hence, will further increase in the reverse leakage current. Thus, this process leads to the vanishing of the depletion region. So, due to this continuous process, at particular moment, depletion region vanishes. At the junction, at some temperature, depletion region of J2 vanishes. At this temperature, the SCR will get turned on. Light triggering. In this, we can observe the figure here. Here a niche or recess is made, that is in the inner P layer. In light triggering, a pulse of light of suitable wavelength guided by the optic fiber is irradiated to turn on. So what is light triggering is, we use light energy to trigger the or turn on the SCR. That is when the niche is irradiated, the electron hole pair will be generated. If the intensity of irradiated light is exceeds a certain value, then this SCR will turn on. Irradiated light produces, it works as same as when we provide the gate pulse. That is, irradiated light produces free charge carriers, which is just like in case of the gate current. These charge carriers move near the reverse bias junction J2 and reduces the forward breakover voltage. This is the reason the SCR gets turned on.